we need to talk about brackets. Brackets are an area of algebra that causes constant confusion. Students frequently get mixed up where brackets appear in questions. And I think there's a good reason for that. I think the reason why students get mixed up about brackets is because there are two different ways of thinking about brackets that people very easily confuse. First of all, with brackets, we have brackets in this sense. 2 times 3 plus 4. So we've got a pair of brackets here. What's the purpose of those brackets? Well, in this situation here, those brackets are probably most commonly thought of as telling you to do this first. It is the B in BODMAS. Now, I'm not going to go into this in huge detail today because there's another video linked below which covers BODMAS and order operations. But just briefly, I'll show you this now. So here, if we didn't have the brackets, then we would have a 2 times 3 plus 4. We would do the multiply first. But because we have a pair of brackets here, that, if you like, prioritizes, it promotes the plus. So in this case, we would go 2 times, well, 3 plus 4 is 7. And 2 times 7 is 14. So one way of thinking about brackets is they're to do with the order in which we do stuff. They promote things inside them to do this first. But there's another way of thinking about brackets. And that other way is, if you like, groups of things. And to demonstrate this, let me give you an example. Supposing I had the following. I had an apple and I had £10. And my apple and my £10 I'm going to put into a bag. So here's a bag containing the apple and the £10. And supposing I had another apple and another £10 that was in another bag. So what I've got here then is I've got 2 bags, each with an apple and £10. So if someone asks me what I've got 2 bags, each has got an apple and £10 in it. But supposing that I empty the bags out. So I'm going to get rid of these bags now. So there's the first bag emptied out, and that's the second bag emptied out. And I just put what I've got down in front of me. So what have I got? Well, I could say I've got 2 groups, I suppose, of a bag and £10. More likely what I'm going to say there is I've got 2 apples and £20. So 2 different ways of describing the same thing, either 2 lots of an apple and £10 or 2 apples and £20. They're equivalent. Now let's look how we could, or how that relates, I should say, to algebra. Supposing we saw this, expand 2 brackets x plus 10. So here I've got an x and a 10. But I've got 2 lots of that, 2 groups of an x and a 10. And then we see this word here, expand. There's a few different versions of that. Expand, remove the brackets, multiply out the brackets, but they all mean the same thing. They mean find a way of writing this thing here without brackets. Okay, how would we do that? Well, it's exactly the same as the apples thing. If I've got 2 lots, in fact I could even do a little picture here. I've got an x and a 10, that's one lot of x plus 10. Another x and a 10. So I've got 2 groups of x plus 10. But another way of saying exactly the same thing is 2x plus 20. These are equivalent things, equivalent statements. There is no difference between that and that except in how they appear. Let's try another one. I've got 4 lots of y plus 3. Now again, we'll just draw a little picture here. So we've got a y and a 3. I've got another y and a 3. another y and a 3, and another y and a 3. So I've got 1, 2, 3, 4 lots of y plus 3. What's another way of saying that? Well, if we now cut it this way instead, we could say I've got 4 y's, 1, 2, 3, 4, and I've also got 4 3's, 3, 6, 9, 12. So instead of saying 4 brackets y plus 3, I could say I've got 4y plus 12. Now, of course, every time we do this, we don't want to have to write out a series of pictures and diagrams and bags, etc. So what we would say here is, and it's why you often see this called multiplying out the brackets, what we say here is that when we have a pair of brackets that we don't want, we multiply everything on the inside by the number on the outside. 2 times x is 2x, 2 times 10 is 20. 4 times y is 4y, 4 times 3 is 12. But again, we're not doing that because it's something that a maths teacher invented one day. This is because it's the way the world works, just like it was with the apples and the money we saw a minute ago. Right, I'm just going to clear these questions off, put some fresh questions on the board, and then we'll have a look at those and see if we can extend that idea to a few slightly more complicated questions. So we'll be back in a minute. Okay, so 3 fresh questions here. Not a huge step up from what we've just seen. The main difference here is we start getting negatives thrown in. And as I've said before, and I will say again many times, negatives are one of the things that cause people to make mistakes in algebra. Lots of mistakes in algebra. Right, let's look at this first question here. I do quite like these arrows. You don't have to do this at all. I just think often students find it quite helpful. So 4 times x would be 4x. And 4 times minus 2, well, a plus times a minus is a minus, and 4 times 2 is 8. So these again are 2 different ways of saying the same thing. 4 brackets x minus 2 is exactly the same thing as 4x minus 8. Okay, we've got minus 3 times y. Well, 3 times y would be 3y, but we've got minus 3 times y, that's just minus 3y. All we can do is put the number and the letter, if you like, the unknown, next to each other. And we've got minus 3 times positive 7. Well, a minus times a plus is a minus, and 3 times 7 is 21. And last question here, we've got minus 2 times y. Oh, I didn't do my arrows here. That's entirely up to you. Again, let me stress, I quite like doing that. Some students like it. If you want to do it, great. If you're not fussed, don't worry. So minus 2 times y is minus 2y, and minus 2 times minus 1, here's where it could easily go wrong. So we're doing a minus times a minus. That is one of those situations where a minus and a minus make a plus. When you're multiplying 2 negatives, you get a positive. And 2 times 1 is 2. There's also going to be a link below to a video I've done on negative numbers. By all means, go and have a look at that at some point. In fact, I would recommend you watch that as often as you can, because it's such a useful thing to be able to handle your negative numbers. Right, a few more questions to do, so I'll just clear this off and back in a second. Okay, so 3 more questions. These are all a little bit more abstract, a bit more strange. Here we've got x groups of something. So we don't even know how many groups there are. That's part of the unknown. That is a little odd, but the basic method here is exactly what we saw before. We're going x times x. In fact, let me put the arrows in here if you like those. So x times x, that is x squared. And then we're doing x times 3. Well, it's positive x times positive 3, so that's positive, and it's x times 3 is 3x. Next one here, we're going x times y. Well, that's just xy. Nothing much we can do, just stick the x and the y physically next to each other. We've got an x times a minus x. Well, it's a positive here times a negative, so that's negative, and x times x is x squared. Finally here, we've got minus y times x. Okay, so we've got a minus times a plus. Well, that's a minus. Now, y times x, we could write there yx. It's more normal in algebra to see things put in alphabetical order. In an exam, you won't lose marks if you don't, but if you're checking answers in back of textbooks, that kind of thing, you'll normally see they put it in alphabetical order. So rather than yx, I'm going to write that as xy. And then we've got minus y times minus z. Well, again, we've got a minus times a minus, which makes a plus, and y times z is yz. Again, we'll put it in alphabetical order. Okay, I'm just going to clear these questions off. I've got 3 more questions to finish off, and then we'll be done for this video. Okay, last 3 questions for today. So start off with this one here. We've got 2x times 3x to begin with. Let's put my arrows in over here. Well, 2 times 3 is 6, and x times x is x squared. That gives us 6x squared. Now, I've said a few times before that when you're multiplying terms here and you don't see a number, that's an invisible 1. So if you're not sure what to do here, people often look at this and they've done the 2 times 3, that's fine. They hit this bit here, they just don't know what to do. But 2 times invisible 1 is 2. Oh, I should have said before, it's plus times a plus is a plus. So plus 2, and x times y is xy. Now for this question here and the one underneath, you'll notice that we've actually got 3 terms inside the brackets here. That's fine. Most of the time, if you're looking at textbooks, they'll have 2 terms. There's no particular reason for that. They just tend to, that's what they tend to have. But there's no limit to how many terms you can have inside brackets, just like there's no limit to what you can have, if you like, inside the bag. So this is perfectly fine, and we treat it in exactly the same way. So 5 times x is 5x. Multiply these, so we've got 5 times 2, again it's plus times a plus, and 5 times 2 is 10, so that'll be 10y, and then we just do one more multiplication. So 5 times 3 is positive 15, and 15z. So nothing any harder than having 2 terms, just multiply each of the things on the inside by the number on the outside. And last one we've got here. Now, as soon as I look at that, little alarm bells are going off, because this is the kind of question that will cause problems. Have a think for a second why you think that would be. What is difficult about that question, or more likely to cause problems with this question compared to this question here? And the thing that's going to cause problems there is the negatives. Particularly having 2 negatives here is going to cause students to make mistakes. Right, so let's have a look. Minus 6 times a, well, it's a minus times a plus, that's minus. That'll be minus 6a. And here's where people will go wrong. We've got minus 6 times minus 2. So that's a minus times a minus. And a minus times a minus is a plus. So that'll be minus 6 times minus 2 is plus 12b. And finally, we've got minus 6 times plus c. Well, a minus times a plus, again, is a minus. That'll be minus. 6 times invisible 1 is 6, and then don't forget the c there. Right, that's the last question. I've got a couple of extra little things I want to finish off by saying, and then we'll be done. Now, if those last few questions were getting difficult, and I think they probably were, why was that? A couple of reasons, I think. One was because they had negative numbers, and again, that causes lots of problems. The other was they had quite complex terms with lots of x's and y's and xy's and numbers in front of the x's, so 5x times 2. That gets complicated. They weren't getting complicated because of the expanding. The expanding tends to be the same every time. There's only really one way you can make a significant mistake with expanding, and that's just to forget to expand. So I do quite often see people put that. That is definitely wrong. What's happened there? Well, someone might have remembered that expand means, if you like, get rid of the brackets. So they literally just got rid of the brackets. If they've done that, they're not thinking about what they're trying to achieve. What they're trying to achieve here is to say, well, I've got 5 groups of something. What's another way of saying the same thing? So that's the last words, really. Just with expand, try to make sure you're okay with the fundamental idea of groups, of getting rid of, taking those groups and putting them into, if you like, into one big group of things. So that wouldn't obviously be 5x plus 2. That would be 5x plus 10. And again, just to finish off, why is that? Because if I have got 5 groups of x plus 2, 1, 2, 3, 4, 5, that's just the same thing as 5x's, 5x, and 10. If you've understood that concept, then expanding is far less likely to cause any difficulties. If it does, it won't be the expanding, it'll be the other things. Negatives, again, is by far the most common problem. Right, that will do us for today, so I will see you soon.